Yep, it is recording. Multiplying and factoring. It is.
Why do you do that? Why not?
Are you on pressure when you're recording?
Not at all.
Okay.
The whole nerves and teaching thing was gone like 17 years ago. This is just being my 18th year. Okay. I remember thinking like, it was my first year of teaching because I taught elementary school, how the heck am I ever going to be able to speak to these kids for like 7 hours a day? Like, how is that even possible? It's a little overwhelming at first, for sure. First thing I'm going to write is not example 1, though. You are going to take math notes in 2 different colors. How many people have 2 different colors? Right now. Like, you already have them out. Good. So, like 5, 6 of you, maybe 7. So, all of you use different colors when you take notes because it helps you remember. So, the first thing we're going to write is multiply numbers at exponents. Multiply numbers at exponents. So here's the first example. Connor, please don't talk when I'm talking. So example 1, we have negative x cubed. Actually, I'm going to make it negative 2x cubed. 9x to the 4 minus 2x cubed plus 7. Multiply numbers at exponents. Jacob, what's it called when we multiply it into the parentheses? Jacob, just Jacob. I heard like 4 people say it. If I have questions, please just Jacob. Okay, can you distribute the first one for me, please? You made one little mistake already. Not 18, but negative times the positive is what? Negative 18. Okay, negative 18x to the 7. Perfect. So negative 18x to the 7. Let's raise your hand if you know the second term, Maggie. Okay, go for it, Maggie. We can't, why can we not subtract these? Okay. Different exponents, that's why you can't subtract them. Perfect question. Alright, distributing the second one, raise your hand if you know. Okay, go for it. Positive or negative?
Positive.
Okay, and then how about the last one? Raise your hand if you know. Chloe, tell me. Multiply numbers. Negative 2 times 7 is what, Chloe? Negative 14. You do know. And then what? That's just write that next to it. That's it, right? X cubed. Okay, multiply numbers at exponents. So I want to show just kind of a common mistake you guys make. No, I don't want to subtract, I want to multiply, add and multiply. What do I get on the left? Do you know, Dave? All right, let's do this first, and then I'll take your question. What do we get over here?
X to 4.
Nope. Nope. Yep.
Oh,
Can I borrow that real quick? How many of these do I have? Two what? Let's say they're both 10. Okay? So it's just 2x squared. The 10 don't suddenly square, right? So this one equals 2x squared. So when you're adding them, don't add the exponents, moral of the story. Leave the exponent alone. And then what do you get when we multiply these two? Raise your hand. Dave. X to the 4th. Okay, you getting the difference between these two, right? They look exactly the same, except one's adding, one's multiplying, is really important. Because I see this mistake again and again and again. So, like, write it down, highlight it, write it in different color, whatever you need to do, because I see that mistake all the time. Right? I have 1 puppy and 3 puppies. How many puppies do I have? 4 of them. I don't have 4 puppies squared. I have 4 puppies, right? 1 pen plus 1 pen, 2 pens. Not 2 pens squared, it's 2 pens, okay? Alright, so that's important. Alright, Dave, you had a question on the one above though.
So, 7 and 2, that's the negative 14. Why did you forget?
Because what I'm multiplying, when I multiply negative 2x cubed times 7, like the x cubed can't just go away, right? It's still there. So that would equal negative 14x cubed. That was freaky. You do, exactly. Yep. Okay, good question. It clears up questions for others. Connor. Negative 18, x to the 7th, right? Yes? That makes a big difference, buddy. Okay, then just don't ask the question. That's the final answer. What could you do? Tell me what you can do. Right? We can't add or subtract anymore because all the exponents are different. You can only combine the like terms if the exponents are the same. It's a good question, despite the fact that you didn't really care. I just told me what you said, man. That's all. Okay, example number 2. Now we're going to be talking about greatest common factor. So yeah, GCF, and let's say we have so we want to think about the biggest number you can divide out of each. 2 and 5, those two good. You're not thinking about it in the way I want you to. I understand what you're saying, but you need to tweak it a little bit. What's the biggest number that I can divide out of each? Like, it's got to be the same number that's the common part of greatest common. Bigger than 2. 4. Back? 4. Okay? I can divide a 4 out of each term. So I'm going to share it like this. Then what's the smallest number of x's? The least amount of x's. 4. There's 2 x's in the first term and 1 x in the second term. What's the smallest number of x's? 1x. So I'm going to divide that x out. This is my GCF. Okay, you just got to deal with it and we'll do more problems and you'll understand. So you like to get angry when you don't get it, so don't get angry and just say it until you understand it, because you will. You always do. So just be comfortable with that. So here's what I do when I'm factoring. So now we're going to factor. We did the greatest common factor. Now we're going to write this in factor form. So you know when we distribute it, we're going to do the opposite of distribute. We're going to pull out the greatest common factor, and then write what we have left in the parentheses. So what I do is I take that 4x and I write it in front of the parentheses. And then, Ben, what's 4 divided by 4? 1. What's x squared divided by x? So if x squared divided by x confuses you, it's just like that. I have 2 x's on top, 1 on the bottom. What cancels, what doesn't cancel, what's the last, however you want to. 1x left because these 2 cancel. Right? So another way to think about it is, what do I do? Raise your hand if you know the answer to this. What do I do when I have exponents top and bottom in a fraction? Subtract them, right? 2 minus 1, so I have 1x left. Sarah, what's the second part of the parentheses? 5. Right? Because 20 divided by 4 is 5, and the x's cancel. So the greatest common factor is 4x. When we write it in factored form, it's 4x parentheses x plus 5. Okay? Let's do another. Do you have questions? Go ahead. It is not possible to solve it any further. Yep. I did 20 divided by 4, which is 5. And then the x is just canceled top and bottom. Just like, what's 2 over 2? 1. So what's x over x? 1. 5 times 1 is still 5. Okay? Yep.
So it's like the 4x is
Yep. Yep. Alright, let's do one that's a little more challenging. So let's do okay, raise your hand once you know what the biggest number you can divide out of each number is. What's the biggest number you can divide out of each? Jacob. Yeah. You like that doubts all of a sudden, huh? Yeah. 3. Perfect. Good job. What's, Riley, what's the smallest number of x's? X to what power?
Oh.
X to the second. That's where I divide out.
8 to 1.
Right, because this is the least x squared, it's the smallest one I have. So I divide that out. Okay? So then, what's that called? 3x squared? That's the factor. GCF, right? That's our greatest common factor right here. So some of the problems in your homework only ask for the greatest common factor, so that's all you have to write. Okay, all you have to write is 3x squared. If they want you to factor it, I'm going to tell you exactly what the directions say, just so, yeah, they just say factor each polynomial. So if it says factor each polynomial, we talked about it on Friday. Polynomial means, what does it mean as far as the number of terms? Grady? No? 4 or more, polynomial. And then it also means like an overarching term to represent any number. Okay? Except when you have a variable in the denominator of a fraction. Because then the graph is weird stuff. Basically. Yeah. I have no idea what you're talking about. What is it? A term is separated by plus and minus. So 3x to the fourth is 8 terms, 12x cubed is 8 terms, and 24x squared would be a term. That would be a trinomial, exactly. Right? Anyone remember what the fourth called? I told you fourth term, but the actual name, Emma? Hello? Do you remember? What did you say? Quartus. Okay. Right. There you go, man. Alright, so we have 3x squared. What's left out of that first fraction, Brian? Who's going to put his phone on my desk? Oh, the one in your hand, your left hand. Can you come put that on my desk, please? And answer the question at the same time. You'll be multitasking, which would be cool. So 3x to the fourth divided by 3x squared is what?
X to the second.
Perfect. Good job. Okay, now we have the second term, 12x cubed divided by 3x squared. Raise your hand if you know what it is. 12x cubed divided by 3x squared. Danny. She wasn't raising her hand. She had her hand next to her headband, but she can do it. What's 12 divided by 3? 4. She looks so happy about it, too. X cubed divided by x squared. X. Perfect. Good job. And then the last term, what is it, Emma? 8. No x. Okay, x squared divided by x squared goes away. No. See? You're so angry at first, right? And now you're smiling because you get it. Jordan, question. You subtract from numerator to denominator. So 4 minus 2 is 2. 3 minus 2 is 1. 2 minus 2 goes away. Okay? Yep.
Did you distribute or no?
If you distribute, you just end up back where you started. So if you want to check your problem, good idea to distribute. Like on a test or a quiz, I do it. Well,
You mean that like work? If you have to like to show your work, and that's part of it, like having your like three.
sometimes we've made you do a check step. At this point, I don't know. Not totally sure. But honestly, if I were taking a test, I would check it because I want to make sure I get it right. Because when I took a math test, if I didn't get an A, it would make me angry. So I would do all those kind of check steps. All of you should think the exact same way. Or you could go from a D to a C, or a C to a B, or a B to an A, or an F to a D. Right? All right, Jacob.
Why are you squaring
I think in my head, what's the smallest number of x's that exist in all three of these terms? X squared. That's what you can take out. I've said it in a whole bunch of different ways over my career of teaching Algebra 1, and I haven't like settled on the best way, but that's how I think about it. The smallest number of x's that I have is x squared, so I can take that out. You could take an x out. Okay? All right, any... Good? All right, let's do... You're going like this. Okay, we'll go. Okay, it was kind of hard to tell. You're good. I guess your question is really good. What's your question, Tom? I don't know. Okay.
Oh wait, no.
So... Oh yeah. Last example. We're going to give you kind of an accident. Guess who's done? All right, so Riley's going to do the whole thing. So Riley, what exponent could I put on the T right here? 1. For 1. Okay, just Riley, please. I know you get it, but give her a shot. What exponent could I put right here on this T, Riley? For 1. Okay, Riley, So I want to multiply numbers at exponents. T squared times t is t to the what power, ready? I'm adding exponents, you didn't add them. 3. So t to the third. Plus what? 1. Do not say that. Brian, please don't do that. Don't lie. T squared times 1. What is that? If we say Riley times 1, what do we have? Right. T squared times 1 is T what? T squared times 1. Who can help with that? What is the equation? You know? T squared times 1? T squared. Who said T squared? Okay, good. I have difficulty understanding why that's challenging for some people. Can anyone think of a way to explain it so they can get it? If you multiply by 1, it's just whatever it was in the first place. I know, but some people get confused. But if we do t squared times 1, like there's nothing to multiply or add. Yeah. I mean, you could just say it's 1 t squared. Does that make it better? Okay, good. So that was better. That was better. Yeah, it's good. I know. That's why I asked if anybody else has different explanation. Okay, now we're going to distribute the second one. George is going to do it. Negative times a positive is negative. So then it's technically like negative 1 times 2 is negative 2. T times t squared. Add the exponent. T cubed. You said it so quietly, you start to hear it. And then negative 1 times negative 1 is positive 1. And then positive 1 t. Okay. So the directions here will say simplify and write in standard form. So why is this not in standard form? Who knows? Raise their hand. Sarah? Because it's what? You just trailed off so I couldn't hear you. Yes, we have to add like terms, right? So the ones with the same exponents are the like terms. So t cubed and negative t cubed. So you could put, again, if you put the 1 in front, that helps a lot of you, right? Emma gets it right because she put the 1. So put it, if it helps you. 1 t cubed minus 2 t cubed is negative 1 t cubed. Combining the green highlight with negative 1 t cubed. What comes next, friends? Standard form. You already dealt with the t cubed. You just meant to say squared?
Yeah,
It's okay. I thought that's what you meant. Plus. Go ahead. Go ahead, Brent. Right? The reason we don't mess with the exponents is because I think it was on this page or the one before. Right? When we add like terms, you leave the exponent alone. When we multiply like terms, that's when you add the exponent. This is really, like when you take a quiz over this stuff, writing this down on your quiz somewhere will help you keep those rules straight. Because it gets confusing with all the rules of exponents, like add here, multiply, subtract, divide, what? Confusing. Great. Yep. So this is in standard form. Why? You combine like terms, but why else? How do you know it's in standard form? Okay. In order from largest exponent to smallest. Right? We have the cubed one first, then the squared, and then the first power. Again, if it helps you to write that little number 1, then write the little number 1. Tom,
So we have like key money.
okay, yeah, yeah, exactly.
So you have to combine them.
You can't combine those.
Only here's a whole.
Only with the X1 and the thing can you combine.